Folks, welcome back to Walter's Aircraft Works, where we're going to convert this RX7 to an EV. It's still Friday, Good Friday, 2017. Our task today is to try to figure out how we're going to attach this AC50 motor to our Mazda transmission. Now we've chosen to directly couple the motor to the transmission. What does that mean? Well, it means the output shaft of the motor, 1 1/8 inch output shaft, keyed output shaft, will connect directly to our input shaft of our transmission. This is a splined transmission input shaft, and we're going to have to machine or create a coupling to hook those two together. Well, we also have to be able to support the motor on the transmission. Actually, when they're bolted together, they'll become one unit, and there'll be 3 points of contact with the vehicle to the regular engine mounts that the internal combustion engine of the RX7 used. So that'll be a little bit farther down the road, but we're going to need to, like I said, create a coupling to couple these two shafts together. Now, to use the splines of the transmission input shaft, I've bought a clutch disc. I bought it off of eBay. I paid, I believe, $35 plus shipping for it. I looked for a used one. All we really need to use is this spline coupling right here. Uh-oh, getting some help. Jetson. Well, that's Jetson making an appearance. Alright, so we need to use this splined coupling right here. A used one would have been just fine. Okay, small interruption there from Jetson, but we're back. This internal coupling, spline coupling, is all we really need. I looked for a used clutch disc. It really, that's all we needed, since we're going to take most of this apart, or take it all apart, and just use this internal coupling. I didn't need any of this friction material, didn't need new friction material, but this is all I could find. So my plan is to take this apart. It looks to me like if we drill out some of these rivets, grind these rivets off, that this internal spline coupling will come off, and then we will be able to use the lathe and create a steel coupling that'll either weld to or bolt to, and then slide over this shaft. We'll have to broach a 1/4 inch keyway in it, and then I'm not sure exactly how we're going to tighten it onto this shaft, or if it's even that important to tighten it onto this shaft. It's going to be keyed. This output shaft will be butted right up to the end of this input shaft for the transmission. So once we get the drive coupling on there, there's really no place for it to go. This distance will be reduced. This output shaft should be buttoned right up close to the end of this input shaft, and the drive coupling connecting the two of them. Did a little bit of a drawing here. Apologize, I'm not a great artist, but maybe this will explain a little bit better about what's going on. This represents the motor, transmission, input shaft or output shaft of the motor, input shaft of the transmission, and adapter plate, and oh my goodness. Alright, sorry about that. Had to stop and love on the cat a little bit. He requires a lot of attention, and hey, he doesn't care what's going on. He's going to get it. Alright, so back to the drawing here. Motor, output shaft, drive coupling, adapter plate, transmission input shaft, and transmission. This is what we're going to have to build on the lathe, using that part from the clutch plate to connect the input shaft of the transmission to the output shaft of the motor. Alright, so that's what we're planning on doing, is getting started today on laying out the groundwork anyways for the adapter plate and this drive coupling. Let me change some things around and get set up, and we'll get started. Okay, with just some quick dimensions here, the distance from the end of this output shaft of the motor, and this faceplate here is 1 7/8. So 1 7/8. If you draw a line or place a ruler across the bell housing and measure how far this input shaft sticks out from that plane, it's just 1/8 of an inch. It just barely sticks out. So the distance that we have to work with there is easy math there, equal to 2 inches. The best we can do without modifying the input shaft or the output shaft, definitely don't want to mess with this nice pretty output shaft here. The best we can do is 2 inches. We will need 2 inches of space between the flange of this bell housing and the flange of this motor. We could, if we get in a pinch, don't want to have that much space between the two of them, we could cut this input shaft off. We could grind it off. We don't really need it when you're using it on the normal internal combustion engine and the clutch and pressure plate setup. This normally rides in a bushing or a bearing. They call it a pilot bushing or a pilot bearing, and that supports the end of this shaft. We don't really need that because the motor and the transmission are going to be coupled together all the time. In an internal combustion engine, they aren't. When you push in the clutch, then that uncouples the engine to the transmission, and you get free spooling in here, which then lets this shaft kind of move around. That's what pilot bearing does, is keeps that shaft from wiggling around too much. Well, we don't need that because it's going to be coupled together, basically permanently put together. This bearing on the end of this motor will then help support this shaft. So if we need to, we can trim this on back. I think we'll try not to if we don't have to, but if we need to, then we will. All right, so what are we going to use for an adapter plate? Well, I happen to have this piece of 5/8 inch thick aluminum. Was left over from another project, so I think it's going to work good to make this adapter plate. How are we going to lay it out? That's our next plan. All right, I decided to make a template. Seems like the easiest thing to do, and how I'm going to do it is use this. This is an old door face off of an old melamine cabinet that I've repurposed for other stuff. But I've drilled a hole in the center of it. I've got a piece of I don't know, it's cardboard my wife brings me from work, and I love using it for template material. What I'm planning on doing is standing the transmission up on this cabinet door with the output shaft in the hole there, using a pen to trace around the outside of the bell housing as well as the bolt holes and any other thing that we need to trace around. Then we can cut this template out, lay it on our piece of metal, and move it around and see how much material we're going to use up. All right, so I'm going to draw a pencil line around it, or a pen. I use a pen, I guess, and mark it, scribe it, and then we'll take it back apart and cut out our template. All right, so I just wound up just tracing around the outside of the bell housing here. I wound up using a pencil, this mechanical pencil that I have. Seemed to work pretty good. The ink pen didn't work so well as I rolled it up underneath places like here. It kind of laid it down on its side too much and wouldn't work very well. I also used a punch here, just really a round piece of stock that I chucked it up in the lathe and drilled it and then countersunk it, made a sharp edge around the outside, and then took my hammer and just cut through the papers. Seemed to work pretty good. Oops, now I got it stuck in here. It was longer when I did these longer holes. You get the point. We should be able to pull it off now and cut around the outside of the perimeter there and have a pretty decent template to lay out our material. Okay, that worked pretty good. Got the template cut out. Felt like craft day at summer camp, but we got it cut out. Fits the bell housing real well, and I think it's going to be real beneficial for helping us determine best utilization of this slab of aluminum. The intention was to be able to position and cut out our adapter plate, at least the big part of the adapter plate, and then be able to cut two more spacer rings out of this material to go on the face plate of the motor here. A 9-inch motor, 4-inch inner ring here, so basically a donut with an inside diameter of 4 inches and an outside diameter of 9 inches. Be able to stack those on top of each other, one thickness for the plate here for the bell housing, and then two of those donut rings to stack on top. Should equal, well, we'd be just a little bit short of our 2-inch dimension here. We would be 5/8 times 3. Don't look at my math here. This is chicken scratch. 5/8 times 3 would be what, 1 inch and 7/8. So we would be 1/8 of an inch short of our 2-inch mark. So that would be 3 slabs or 3 thicknesses of this material. We would still need 1/8 of an inch of some other material. That's what all this means. But anyways, I don't think that's all for naught anyways, because there isn't enough material here in this piece to get our bell housing piece out of it plus 2 donuts. So we're going to have to come up with some other material, and if I have to come up with more material, then I'll probably just buy thicker material, and we won't have to worry about trimming back this input shaft to the transmission. So stay tuned. I'll try to find some more material, and we'll press on from there. Hey, check that out. With the magic of editing, we're back. We've got the material in hand. Actually, it's been about 4 days. I've been off working the day job. While I was gone, I ordered a couple of pieces of aluminum. I got it from eBay, actually a company called Stoner Tool and Raw Material. These two pieces of 60-61, 3/4 of an inch thick, 9 inches by 9 inches with shipping. Well, actually, they didn't charge me any shipping. Wink, wink, nod, nod. Was $60, $59.98. Might have been able to find it locally a little bit cheaper, but I think it's going to work out well for us. This will turn into hopefully two nice spacer rings, and still use our a big slab here of the 5/8 thick material to create this part. That's next. I guess we're going to have to figure out how to shape these, how to turn them into those donuts, and I'm sure the lathe will be involved in that, maybe possibly the mill, but uh-oh, got some more help. But let me think about that for a few minutes, and we'll get started on that shortly. All right, I'm trying to decide whether I want to scribe around the outside of this template, or just glue the template to the aluminum stock and then trim around the template itself. I'm leaning that direction. I've used this 3M product for a lot of other stuff, and it works pretty good. It's probably a little bit too strong for this particular application. They make some weaker glue that would probably be better. We really don't need this template really stuck to that material very well, but this is what I have on hand, and I'm thinking about just putting a light coat of the adhesive on the template and then sticking it to the aluminum, cutting around the template. A couple other thoughts as well. The hole in the center right now is just, for our template purposes, is just really a reference point, or it allows that input shaft to kind of stick through the hole. But eventually that hole is going to have to be enlarged, or when we get the adapter plate cut out, we're going to have to enlarge that hole to receive, or it's going to have to be big enough to receive without interference the coupling that goes between the output shaft of the motor and the input shaft of the transmission. And what that size of the hole is, I'm not sure it really makes a difference It's not a critical dimension, and probably the more material that we can remove, the better will be. Structurally, I don't think it's going to cause a problem, and we're just going to reduce weight, and that's always a good thing, to reduce weight on an electric car. But right now, I have to think about how I'm going to cut that hole in the center. You know, it's not real critical. It'd be nice for it to be nice and centered up on this hole right here to help us align the spacer rings. It's not super critical, but I'm thinking what I'm going to do to cut that hole in the center is I'm going to use my turntable and the mill. So what that means to us right now is this hole needs to be a particular size to fit my turntable. And let me get that up here on the bench. So, all right, this is the turntable that I have for my Bridgeport mill, and it's a pretty useful tool. I've used it for quite a few projects, and hopefully it'll work well for this one. My idea is to use our template. All right, once again, apologize for the interruption from the mouse patrol. But what we were talking about was once this template, we use this template to cut our part out. I think that we can use this hole here in the template to find the spot in the part where we need to drill the hole that'll keep us pretty well lined up with our input shaft of our transmission. And if we drill that hole to the size of this pin here, which I believe is a 1/2 inch, that'll help us index our part onto this table. And once we get the part located on the table correctly, and we put a sacrificial piece of wood between our part and rotating table, we'll be able to drill through the part, and then in that hole that we create, we can use the mill to lower a bit into that hole and then turn the handle on the table, and the mill will create a nice large hole in our adapter plate for us. I think this is going to work well. There's other ways of doing it. We could use a boring bar setup, some type of fly cutter. I think this is going to create the best hole for us. So I think our next step is we need to lay this template on our material and find the best placement for it to utilize our material the best, and then go ahead and cut the adapter plate out. So let me get that set up. All right, I glued the template to the stock, and just sprayed a little bit of that 3M 77 spray adhesive on there, just a real light coating on the template, and then stuck it. I kind of moved the template around to kind of get you know, the best utilization out of the stock that I could, and then stuck it on down. Task at hand is to center punch this center hole. I found a bearing driver, and then I've pulled out my 5/16 center finder here that slides nicely into this bearing driver. That'll help us center up inside that template there. These holes, I'm not going to center punch these yet. I think once we get the template or the adapter plate part cut out and this center hole cut, we can then set the transmission bell housing back on our part, center it all up, and then use the bell housing holes themselves to center punch these holes, and then we should have a good good alignment. So let me go ahead and center punch this center hole, the input shaft hole, and then we'll get to cutting. All right, we're set up over here on the bandsaw. This is one of my favorite tools in the shop here. This thing just cuts through about anything. But we're going to use it right now. I'm just going to just kind of square things up, or kind of rough cut the material out. And then I'm not sure exactly how we're going to trim it right up to the edge of that template, whether I'm going to do you know, set some kind of milling process up, or do it with the hand grinders or a combination of the two. But I'm going to try to get it pretty darn close with this. This is a great saw and it works well for cutting metal, but it's not real maneuverable. It won't cut really tight radiuses, at least with the blade that I have in it. So it's going to be kind of rough cut, and then we're going to need to do some hand work either with the mill or with the angle grinders, or a combination of the two. So let's get cracking here. May have to change blades. It's cutting pretty slow. Let me swap blades out and see if we can get through it a little bit quicker. We got a lot of cutting to do here. All right, this is a more aggressive blade, and hopefully this will help us get through it a little quicker. Let's give it a try. All right, let's give it another whirl here, a third try. The first blade that we were trying to cut with was well, it's been on the saw for quite some time, and it was 10 teeth per inch. The second blade was a new blade and a little bit more aggressive at 7 teeth per inch, and this one I've gone back to a finer tooth, and it's new as well. It's 14 teeth per inch, and let's hopefully I can get this one to cut straight. Kind of making a mess out of this cut, but we got plenty of time to recover from it, or plenty of material to recover from it. So hopefully this one will cut straight. Let's give it a try. All right, not the prettiest of cuts there, but I think nothing a grinder won't clean up. And that blade did a lot better. Maybe not quite as quick, but definitely it cut truer and seemed to be easier to control. So I think that's what I'm going to use to trim the rest of it up. Hopefully it'll continue to cut well. I won't bore you guys with all the cutting on this, so I'll do most of the rest of it off camera, and then bring you back in when it's time to figure out how to clean it up and make it look good. set up over here on the mill. I got the majority of the adapter plate itself cut out, or at least rough cut. I got a couple little areas here where the radius is real tight, and I didn't just want to come trucking in here with the bandsaw and make a square corner. So I'm going to drill this, and I'm going to do it on the mill so it's nice and vertical, and it's sometimes a little bit difficult to find out what kind of radius or how to match up this radius. And really it's just a shot in the dark here, and it's really not critical, but this is a pretty good technique that I found that works fairly well. I've got a washer here. I've got like everybody probably has an assortment of washers, and this one's a fairly small one, and I just kind of matched the radius of that template, which of course is not very exact itself, but it looks good there. So I'll go ahead and find a washer that matches that radius, and now it's just a matter of taking a center punch again, a hole finder or a center finder, and sticking it right in the middle of that washer, and well, if I can get it in there in the center. Well, let me push the washer back in the radius, grab the center punch again, the center finder, and make sure it's good and squared up, and give it a little tap. Probably shouldn't be using a ball peen hammer for this. There we go. Now we've got the center of our radius. All I have to do is mic the outside of that washer and figure out what the diameter. It looks like it's about 1/4 of an inch. I'll double check that with the micrometer or with the calipers and get a equivalent size. Oh no, equivalent size drill bit, and then drill that hole. We got one more of these holes to do. It's over on the other side, over here, and it's got a little bit bigger radius, and when I get that one set up, I'll turn you back on for that hole as well. Now, this is the other side of the adapter plate, and this radius on this side is a little bit bigger, and just to show you, not that this is rocket surgery or anything, let me show you the process I used. You can see, well, hopefully you can see that washer's a little bit too small for that radius, and this one's, yeah, you can't see very well, can you? But I'll take my word for it. This one's a little bit big. There's just a little bit of a gap here. So this one looks like, to me, it fits about the best. And so again, we can just center punch this hole, and then we know where to start our starter drill and our drill bit to get that radius. If you didn't do some kind of method like this, you can use a compass or template, but it's always, for me anyways, it's hard to determine how far off of this radius do you start. If you just start plunging drill bits in here, it's not going to look very good, or chances are that it's not going to put this radius exactly where you want it. So this method works well for me, and I think you'll see that it works. All right, got the center drill set up in here and punched, and we'll go ahead and drill this, center drill it, and then that washer mic'd out to pretty close to 5/8 of an inch, so probably step it on up in several different sizes up to 5/8 of an inch. But here we go. All right, so this is 1/4 inch. This is the diameter that will drill out the other side, the smaller radius, and then we'll do one more on this one up to 5/8. Well, we're set up on the mill. We might as well drill this center hole. I just mic'd it. The pin on the rotating table is 1/2 inch, and we'll center drill it first and then drill it with a 1/2 inch drill. All right, we're ready to center drill this one. This one's the small radius. It's a 1/4 inch drill bit. That's what we're going to drill it with. So a 1/2 inch 1/8 inch radius. Yeah, I got a little ambitious with the center drill there. I think it's going to be just fine, but probably shouldn't have plunged quite so deep with the center drill. All right, well, back to the bandsaw now to finish up the rough cut, and then we're gonna have to try to figure out how to smooth this thing up and make it look pretty. All right, we got all the cutting done. You can tell that some places I did better than others. The saw blade continued to cut real well. I got very close to the template. Started off being kind of conservative with it, and then wound up going back and trimming more of it off and getting pretty close to the template. So won't be much sanding to do as far as bringing it up to the template, but just more or less sanding the edges, making the appearance look better. You know, that area right there, you can see got a little bit of work to do there to grind it back down to the template and smooth it off, round it out a little bit. But all in all, I'm pretty happy with it. The saw continued to cut well, and left us very little work to do with the sanders. All right, I got you set up over top of my belt sander. It's a 1-inch wide Delta belt sander. Does a pretty good job. I'm going to try to use it on most of the outside corners and the flat spots. Hopefully, trying to keep it fairly perpendicular. I don't want to put any bevels or any rounded edges on it yet. Just trying to keep it pretty, the sides perpendicular with the face on it, just for appearance reasons only. The inside corners we'll have to tackle another way, and I think we'll use the drum sander on my drill press. So let's get started. I got most of the really rough saw marks out of it with 50 grit sandpaper. Now I've switched over to 120 grit. I'm going to try to smooth up sanding marks a little bit, and I think that'll be good enough from there. As you can see, the sander did a pretty good job at cleaning up the outside radiuses, the outside corners did really well, and the flat spots. But these inside corners here are going to need a little bit of work with something else, and I think that something else is going to be a drum sander set up on my drill press. So let me get that set up and we'll give that a whirl. I got you perched up over the drill press with a drum sander in it. This is the biggest, well, not quite the biggest diameter one I have, but a fairly good size one. Looks like it's going to fit in the bigger radiuses fairly well. As we get down into those smaller ones, I'll probably have to change out to a smaller drum sander. Got my drill press turned up as high as it'll go. I don't know what the grit is on the drum sander. It's fairly coarse. So hopefully it'll make short work out of these final saw marks on the inside radiuses. Up pretty good. The edge is pretty smooth. I got into most of the corners fairly well. Pretty happy with it. The real tight radius corners, not quite as smooth as the rest of it, but hey, you're not going to judge me, are you? Think I like it. Think I'm satisfied with it. I'm going to go ahead and try to peel the cover off from it now, or the template off from it, and maybe clean it up a little bit with some lacquer thinner or something to get that zinc chromate off from it. And then I don't know, I might even hit it with the palm sander, knock the edges off a little bit. It is, well, it's not too bad. It's pretty decent. Can't really test fit it on the transmission yet because this center hole is still too small, and got to do some planning on that to figure out. This hole is going to help us index our next project, which is going to be the spacer rings made out of that 3/4 inch 6061. So we don't want to drill this up to the size of the transmission yet. The input shaft for the transmission could bump part of it up. It's only got to come up, I think it's, can't remember, 5/8. I think it's just shy of 5/8, but I could bring part of this hole. And remember, the output shaft or the input shaft only sticks out of the transmission by about 1/8 of an inch. So I could plunge a drill bit in here, you know, 1/8 of an inch or so, and that would let us test fit it. But I'm pretty confident that it's going to fit. So like I said, next time we're going to need to cut those spacer rings. That's going to require probably the mill and the lathe, and I don't know, maybe a little bit of redneck ingenuity as well. But thanks for sticking with me. I know this has been a long video or a long segment, and it's taken us a long time to get to this point. By the way, I compressed a bunch of the cutting and the sanding as well. And all in all, I think I've spent about 3 hours cutting and sanding this adapter plate. Once again, thanks for sticking with me, and come back for episode 2 when we'll do the spacer rings. Thanks for watching.